67P Churyumov-Gerasimenko is a Jupiter family comet. It originally comes from the Kuiper belt. It has an orbital period of 6.45 years, a rotation period of about 12.4 hours, and a maximum speed of 135,000 kilometers per hour. At its widest point, 67P is about 4.3 kilometers long and 4.1 kilometers wide. Comet 67P was discovered on October 22, 1969, by the Russian Almaty Observatory. Klim Ivanovich Churyumov discovered the image of the comet while examining a photographic plate of another comet taken by Svetlana Ivanova-Gerasimenko on September 11, 1969. The comet consists of two lobes connected by a narrow neck. The larger lobe is about 4.1 kilometers by 3.3 kilometers by 1.8 kilometers, and the smaller is about 2.6 kilometers by 2.3 kilometers by 1.8 kilometers. With each revolution, the comet loses material as gas and dust are evaporated by the sun. ESA's Rosetta mission tracked Comet 67P Churyumov-Gerasimenko for 10 years. The comet regularly visits the inner solar system, orbiting the sun once every 6.5 years between the orbits of Jupiter and Earth. In August 2014, the European Space Agency's Rosetta spacecraft reached Comet 67P. Once in orbit, it plummeted to an altitude of 10 kilometers to obtain unprecedented data from the comet. Today's Science will feature a series of new articles detailing some of the mission's early discoveries, including findings from Rosetta's flagship science camera OSIRIS, full form is optical, spectroscopic, and infrared remote imaging system. Images like these show that 67P is a much more diverse place than anyone expected. The Rosetta mission was launched from Kourou, French Guiana, on March 2, 2004, and arrived at Comet 67P in early August 2014. Over the next 25 months, Rosetta tracked the comet as it orbited the Sun, conducting detailed studies of its nucleus and the surrounding gas, dust, and plasma environment. During this time, 67P traveled a heliocentric distance of well over 3.5 astronomical units during its perihelion pass at 1.24 astronomical units in August 2015, and again up to nearly 4 astronomical units on the return journey. Depending on the comet's outgassing activity, Rosetta remained within tens to hundreds of kilometers of the nucleus for most of its mission. The majority of the mission was spent in its gravitational boundary orbit and within the terminator plane, within 30 kilometers of the core. Combined with the comet's rotation, Rosetta covered the entire surface, allowing the probe to repeatedly fly over the same latitude and longitude, studying the long-term evolution of the nucleus and its surroundings. The mission ended at the end of September 2016, when the Rosetta probe itself landed on the surface of the comet. Churyumov-Gerasimenko orbits the Sun in an orbit that intersects with the orbits of Jupiter and Mars, approaching but not reaching the orbit of the Earth. Like most comets in the Jovian system, it is thought to have fallen from the Kuiper belt, a region beyond the orbit of Neptune, as a result of one or more collisions or gravitational forces. Analysis of the orbital evolution of the comet has revealed that until the mid-19th century, it approached the Sun within 4.0 astronomical units, about 600 million kilometers, or about two-thirds of the distance between the orbits of Mars and Jupiter. It was too far from the heat of the Sun to form a coma or tail, making it invisible from Earth. Comet 67P Churyumov-Gerasimenko made history as the first comet on which a robotic spacecraft orbited and landed around Earth, the Rosetta spacecraft, carrying the Philae lander, encountered the comet in August 2014 and accompanied it on its journey into and out of the inner solar system. Rosetta was a mission of the European Space Agency ESA, with NASA providing key instruments and support. The mission ended in September with the spacecraft's controlled impact with the comet's surface. 2016. Comet 67P Churyumov-Gerasimenko is rich in organic molecules that are much more complex than scientists expected, and some of these molecules have never been observed near a comet before. The team, which included scientists from the University of Bern in Switzerland, carried out the study using data collected by the Rosetta spacecraft between 2014 and 2016 and analyzed by the Rosetta mass spectrometer. Rosetta and its follow lander, which landed on the comet, reached Comet Churyumov-Gerasimenko, or Chury, as scientists call it, in 2014. And 2 years later, Rosetta intentionally plunged into the comet, ending its mission. Rosetta's key discoveries included the collection of a huge amount of data on the properties of the comet's interior, surface, surrounding gases, dust, plasma, and more, as well as the discovery of water vapor inside the comet, which is very different from the water vapor found in the comet. On Earth, molecular nitrogen and oxygen were detected for the first time in a comet, the presence of exposed water ice on the comet's surface, and the amino acids glycine commonly found in proteins and phosphorus, a component of DNA and cellular membranes, were found in the comet. The comet's bilobe shape is the result of a gentle collision between two bodies at low speeds, called a contact binary. The terraces, the inner layers of the comet exposed as the outer layers were partially peeled away during the comet's existence, point in different directions in the two lobes, suggesting that the two bodies merged to form Churyumov-Gerasimenko. Rosetta is an ESA mission with contributions from member states and NASA. Rosetta's follow lander is being developed by a consortium led by German Aerospace Center, Cologne Max Planck Institute for Solar System Research, Göttingen French Space Agency, Paris, Italian Space Agency, Rome, JPL, a division of the California Institute of Technology, Pasadena, manages U.S. participation in the Rosetta mission for NASA's Science Mission Directorate in Washington. Ground-based observations suggested that if 67P's activity remained the same from orbit to orbit, Rosetta would send back images of the active nucleus if it encountered the comet. Over the next year, as the comet approached the Sun, Rosetta mapped its surface and studied changes in its activity. As the ice evaporated, instruments on board the spacecraft studied the dust and gas particles that surround the comet and trail behind it in a tail, as well as their interactions with the solar wind. Comet 67P will make its closest approach to Earth in 2021 and will not return for another 200 years. Comet 67P Churyumov-Gerasimenko approached Earth by 62.8 million kilometers, closer than Mars, and left Earth's vicinity by 2214.